The universe might be older than the universe. Hold that for a second, because it sounds like nonsense, and that is exactly the problem. For 100 years, we have told ourselves a clean story. 13.8 billion years ago, there was a beginning. Before that, nothing. No space, no time, no before. The Big Bang was the first page, and everything we are and everything we can see is written after it. Then we built a telescope, pointed it at the oldest light in the sky, and it started sending back pictures that do not fit the story. Galaxies that are too big, black holes that are too old. Light coming from places that, by every model we trust, should still have been drowning in darkness. And a small number of physicists, serious ones, are starting to ask a question that used to get you laughed out of a room. What if the Big Bang was not the beginning at all? What if it was just one beginning, in a chain of them, stretching back forever? That telescope is the James Webb Space Telescope. And by the end of this, you will understand why astronomers now quietly split their entire field into two eras, before Webb and after. If you are finding this as unsettling as I do me a favor and hit that like button, subscribe so the next one finds you, and tell me down in the comments where in the world you are watching from right now. And while you are down there, I want your honest answer to this. If we prove tomorrow that our universe is just the latest in an endless line of universes, would that make you feel smaller? Or would it finally make you feel like we belong to something that never ends? Argue about it, I will be reading. Now let me show you what Webb actually saw. To understand why these images are so disturbing, you have to go back to the darkness. Not the darkness of empty space tonight, a different darkness, the oldest one there is. For the first few 100,000 years after the Big Bang, the universe was a furnace. Too hot for atoms to even hold together, a fog of bare particles glowing white-hot in every direction. Then it cooled enough for the first atoms to form, mostly hydrogen, and that fog cleared. And what came next, astronomers call the Dark Ages. It is not a metaphor. The universe genuinely went dark. There were no stars yet, no galaxies. Nothing burning. Just vast, cold clouds of hydrogen gas drifting in a blackness so complete that if you had been there with human eyes, you would have seen absolutely nothing in any direction for millions of years. The lights had not been switched on. The first chapter of everything is a chapter with no light in it at all. So here is the first thing that should not be there. When Webb and other instruments stare into that era, into the gas that should be perfectly dark, they sometimes catch light coming back. A very specific kind of light, a fingerprint of hydrogen called Lyman alpha emission. It is the signal you get when hydrogen is being energized, lit up, ionized, and it is escaping from a time when, by rights, there should be nothing to light it and no way for that light to get out. Because that early hydrogen fog was not just dark, it was opaque. It absorbed this exact kind of light. Lyman alpha should have been swallowed whole, snuffed out before it traveled any distance at all. And yet, here it is, crossing 13 billion years of space to land on a mirror floating beyond the moon. Light that should not exist, from a darkness that should have eaten it. The answer to that puzzle is the moment the lights came on. The first stars did not just glow, they were monsters. Hundreds of times the mass of our sun, burning ferociously hot and dying fast. And the radiation pouring off them did something violent to the gas around them. It tore the electrons off the hydrogen atoms, ionized them, and carved out enormous bubbles of clear, transparent space in the middle of all that fog. Think of it like a flashlight switched on inside a thick mist. At first, the light just dies a few feet out, but turn on enough of them in enough places and the bubbles start to overlap and merge until they punch open channels through the murk. Lyman alpha light, born deep inside one of those early galaxies, finally had a clear road out. That is what Webb is catching, the exact moment the universe stopped being dark. Astronomers call this whole transformation the Epoch of Reionization, and it is the dividing line between a cosmos full of nothing but cold gas and the bright, structured universe we live in now. We are, in a real sense, watching creation flip its first switch. And that would be a beautiful story on its own, a satisfying one. The problem is what Webb found on the other side of that switch. Because in among the early galaxies, Webb has spotted objects that do not behave like galaxies at all. Two of them, in particular, have made astronomers genuinely uneasy. They are faint, ancient, and they sit so far back in time that they appear to exist right at the edge of the Dark Ages, or in a strange way, beyond it. Their light does not match the patterns we see from the galaxies we know. They look like something else, something we do not have a clean name for. And whenever Webb finds a thing it cannot categorize this deep in time, it forces astronomers to confront the single most loaded number in the whole field, redshift. Let me explain redshift simply, because it is the key to everything that follows. As the universe expands, it stretches the light traveling across it. The further away something is, the longer that light has been traveling, the more it has been stretched, and the more its color shifts toward the red end of the spectrum. High redshift means far away. And because light takes time to reach us, far away also means far back in time. A galaxy at redshift 1 is showing you what it looked like billions of years ago. A galaxy at redshift 10 is showing you the universe when it was a toddler. So when Webb reports an object at extremely high redshift, it is not just saying that thing is distant, it is saying that thing existed when the universe was almost newborn, and here is the trap. If you find a fully formed, massive structured galaxy at a redshift that high, you have a contradiction on your hands. Because the universe at that age in our standard model simply has not had enough time to build something that big. The construction project takes longer than the time available. Something is wrong with the clock, or wrong with the construction, or wrong with us. So let me give you the catalog, the actual record holders, because the names matter and the dates matter. For a while, the most distant confirmed galaxy we had was a little point of light called GNZ 11. It sits at a redshift of about 11, which puts it around 400 million years after the Big Bang. 400 million years sounds like a lot until you remember the universe is 13.8 billion years old. On that scale, 400 million years is the first morning. Then Webb pushed further and confirmed a galaxy called GSZ 13. Deeper still, older still. And then it started flagging candidate objects sitting at a redshift of around 16, which would drag the timeline back to barely 250 million years after the beginning. Each one of these is a galaxy that, by the math, had almost no time to assemble, and yet there it is, already burning, already shaped, already full of stars that had to be born, live, and die to forge the elements we see inside it. But GNZ11, that first record holder, had one more shock buried inside it. When astronomers looked closer at its light, they found the signature of something feeding at its center. A supermassive black hole, the most distant black hole ever confirmed, switched on and growing just 400 million years into the life of the cosmos. And it is not small. It is millions of times the mass of our Sunday. And that is where the unease turns into something closer to alarm. Because we have theories for how black holes grow, and every single one of them needs time. A black hole grows by feeding, and there is a hard speed limit on how fast it can feed, set by physics itself. The radiation from all that infalling material pushes outward and chokes off the supply when it tries to eat too fast. So you start with a seed, a collapsed early star maybe, and you let it eat at the maximum allowed rate, and you wait. And the math says you cannot grow a black hole that massive that quickly. There is not enough time between the Big Bang and GNZ 11 to get from a stellar seed to a monster of millions of solar masses. The clock does not allow it. And yet the clock is wrong, because the black hole is right there. So sit with where we are. Galaxies too large for the time available, black holes too heavy for the time available. Over and over, Webb keeps finding a universe that looks older than it is supposed to be, that built its furniture before it should have had the wood. And when a pattern shows up this many times, this consistently, scientists stop blaming individual measurements and start asking whether the framework itself is broken. There are broadly two ways out of this, and they could not be more different. The first is the conservative answer, and it is probably the right one, and it is still strange enough to rewrite textbooks. Maybe galaxies just formed faster in the early universe than we ever believed possible. Maybe the conditions back then, the density, the chemistry, the rawness of everything, let gas collapse into stars with a speed and efficiency we have never seen and never modeled. In this version, the universe is exactly as old as we think. We just badly underestimated how quickly it got to work. It is like assuming a city takes a century to build and then discovering it went up in a decade because the builders were faster and hungrier than anyone imagined. This idea keeps the 13.8 billion year timeline intact, but it forces us to throw out our models of how stars and galaxies are born. That alone would be one of the biggest corrections in the history of astronomy. And then there is the second answer, the one that gets whispered rather than published. What if the universe is simply much older than we think? What if 13.8 billion years is not the age of everything, but only the age of the most recent chapter? This is where a man named Roger Penrose comes in, and you should pay attention because Penrose is not a crank on the internet. He is a Nobel Prize-winning physicist, one of the people who proved black holes were a real prediction of Einstein's equations and not just a mathematical curiosity. And Penrose has spent years developing an idea so audacious it sounds like science fiction. He calls it Conformal Cyclic Cosmology. Here is the heart of it. Penrose looks at the far, far future of our universe, and he sees a strange thing happen. Run the clock forward, not billions, but uncountable trillions of years. Every star burns out, every galaxy goes dark, and eventually even the black holes, the last structures standing, slowly evaporate away into nothing but faint radiation. What is left is a cold, empty, featureless cosmos with no matter, no clocks, nothing to measure scale against. And Penrose argues that a universe like that, infinitely large, infinitely empty, with no way to define big or small or old or young, becomes mathematically identical to the hot, dense, infinitely energetic state at the start of a Big Bang. The end of one universe and the birth of the next are, in his mathematics, the same thing. The cold, dead future of our cosmos becomes the fiery newborn moment of another. He calls each cycle an eon, and our Big Bang in this picture was not the beginning, it was a doorway. The exit of a previous universe that lived and died before ours was even a possibility, an eon before our eon. Now, I want to be honest with you, because the channel does not lie to you. Conformal cyclic cosmology is not the accepted explanation. Most cosmologists do not believe it. Penrose claims there might even be faint marks left in the oldest light, echoes from those evaporating black holes in the universe before ours, and that claim is heavily disputed. This is a fringe idea held by a brilliant mind, and brilliant minds are wrong all the time. But here is why it suddenly matters more than it used to. For decades, an idea like Penrose's was a curiosity with no evidence pointing toward it. There was no reason to reach for it. The standard story worked. And then Webb started pulling back galaxies and black holes that looked too old for the time we have given them. The data did not prove Penrose right, nothing close to that. But for the first time, the universe started showing us things that an older, deeper cyclic cosmos would comfortably explain, and that our tidy single Big Bang struggles with. When the evidence starts knocking on a door you thought was sealed, you at least have to look at the door and understand the scale of what this one telescope has already overturned, because it is staggering. In just a few years of operation, Webb has shattered record after record. The most distant galaxy ever confirmed, the most distant protocluster, an infant city of galaxies forming together in the early universe, the most distant supermassive black hole, one of the most distant individual stars ever seen, a red supergiant magnified by a quirk of gravity. The most distant gravitational lens where the mass of one galaxy bends and warps the light of another behind it. The most distant quasar, a galactic core blazing brighter than 1 trillion suns. Every one of these is an object nobody had ever laid eyes on before this machine. And almost every one of them, in some way, came in earlier, bigger, or more developed than our models said it should. This is not one anomaly you could explain away. It is a whole catalog of them, all pointing in the same uncomfortable direction. The early universe was busier, faster, and stranger than the theory allowed. So where does that leave us, standing here with a telescope that keeps making the cosmos older than it is allowed to be? It leaves us with a question that is bigger than any single galaxy. If our Big Bang was a beginning and not the beginning, then the implications stretch out past anything we can fully hold in our heads. It would mean the universe is not a one-time event with a birth and an eventual death, but something closer to eternal. A chain of universes, each one rising out of the cold ashes of the last, with no first link and no final one. It would mean the Big Bang we treat as the origin of literally everything is just one moment, one frame, in a film that has been running forever and will keep running long after the last black hole in our cosmos sputters out and seeds whatever comes next. We would not be the children of a single creation. We would be one note in a song with no beginning. I find that almost unbearably strange, and also kind of comforting. We have spent our entire existence assuming we live inside a story with a first page, that there was a moment of absolute zero and everything counts forward from it. Webb has not disproven that. The standard model is bruised, not dead, and the most likely answer is still that galaxies simply grew up faster than we ever guessed. But the telescope has done something quieter and more profound than disproving anything. It has cracked the door on the idea that our beginning was never really the beginning, that the darkness before the first stars was not the first darkness, that underneath the question of how old the universe is lurks a worse question, whether age, applied to everything, even means anything at all. We built a mirror, folded it up, flew it 1,000,000 miles from home, and unfolded it to catch light that left its source before the Earth, the Sun, or our entire galaxy existed. And the light came back, carrying a message we are still struggling to read. The universe is older than it looks, or it is faster than we thought, or it is something we do not yet have the words for. And every time we point this thing deeper into the dark, the answer does not get simpler. It gets stranger and older and more beautiful and a little more frightening. We thought we were looking at the dawn. We might be looking at a doorway, and we have only just begun to see what is on the other side of it. Thanks for watching, and I will see you in the next one.